So hello folks, I want to show you how to slice up a battle rifle. So this may be a complete failure, we'll see, because my screen capture software is absolutely atrocious. AVS Studio for you, you've gotten worse over the last few years. And of course my right monitor, which actually is lower resolution, won't even render properly. It keeps causing the model to jump around. So I'm going to use part of my 2K screen here. Pardon all the background noise. I like my desktops busy. So here is a Halo battle rifle. We're going to transform the object up and away, transform it this way, thusly, and we're going to turn it around like this. Except, now, as you know, my 3D printing print bed here is pretty big, but that is not to scale, not even slightly. This is like Lego scale right now. So what we're going to do, we're going to fix that. We're going to go to transform, and you'll see scale X, Y, and Z here. Those scale factors you can use to kind of modify your print. Normally you'd leave them all linked, uniform scaling. The size thing does work, but I don't know actually where it points size is at. And, you know, saying this gun is 40 inches long is kind of arbitrary. Where do you put, do you measure from back here or there in one straight line? Is it just planar like calipers? It's kind of a myth. Honestly, though, if you're within an inch of the game scale, nobody's going to care. And if they do, they should go print it themselves. So, scale. Let's just do a scale of 120. Because that's a lot of times these things scale up to. Last I checked. A long. Oh, look, I'm really backing out now. Except. So, pardon me, you got any gray poupon. Now we've got a battle rifle. And one 3D printer. Oh, that's actually way too big. That's like truck scale. Transform to be point. Oh, the hell of it, 0.75. That'll maybe squash it, but that's still huge. That's what she said. 0.25. What does that do to me? Oh, that's actually pretty good. And actually, it's actually pretty close to the game. It's probably a little big, but we don't care at this point. The point is I want to show you how to actually use a 3D print bed here and take my 9x6x6 print area and divide up parts. So we're going to accept that. Now we're going to file. We're going to save. We're going to actually export, not save. Export it as a print. To print STL. I don't care to see what they're called. And the file we're going to save under is AA Halo BR. We'll call this step 1. 001.stl. Basically, it's the first step. The way I do my file management is that the first step, this way I have save points. If you make a mistake, you can always go back. Trust me, these files are not that big. You can always delete the steps in the end if you have to, but, I mean, you're going to spend 40 megabytes for an entire pistol or, whatnot. Deal with it. So, now I've got this file right here. Right? Right. So let's just go to, click this out. Don't save. I'm doing this because there's an error in Mesh Mixer. Notice how it makes the mesh, kind of the base plate all kind of screwed up. This way I get a clean look. So, first off things here first. That's the Messiah Armory logo. It does not display. That's the LCD screen. These things from the model are never going to be printed directly. If they do, you'll have to do your own custom modeling to recess them. Don't bother. Analysis. Inspector. So these are all things that are not manifold or are screwed up nonetheless. So let's first get rid of these things because we don't care about the logos. And actually, in all honesty, all the firearms I'll be producing will be triggerless. And the reason why is cons don't like guns with triggers. And honestly, if you want them, I'll add it for the model for you, but if you're to buy a firearm from me, unless you actually ask for it, trigger will go bye-bye. It's a liability thing. Now, on the Picatinny rail up here, ignore those. Those will be fixed in NetFab later on. But you can actually go to here and say, hey, that LCD screen, bye-bye, bye-bye. The cocking lever, I'd actually would pull it out of the model right now and actually print it separately. You may want that to be made out of really thick plastic or actually cast out of resin so it's even tougher, or fiberglass and some metal epoxy or whatnot. There is some logo type here we can probably ditch. These are all flat objects that don't really matter. Thusly, there you go. And actually, even in the scope, we can probably put optics if you want to in there, but we're now good at that. Done. So I'm going to go to Edit, Separate Shells. I want to show you what a shell looks like here. This is your object browser. This allows you to actually see all the various parts of the gun. So we're actually going to remove a lot of this. And to remove, these are done in complexity from 1 down to X. So notice that I've done all this, and a lot of the weird stuff is all done. So we're going to take an object, Analysis, Inspector. Notice it has a blue dot there, and that's because it's not manifold. You can see the pink on the inside. Those are the inside normals. Auto repair all. Hey, look, it's now a solid again. So they were pink originally, but if you go through them one by one, you can actually fix most of these little things. And it is a bit painstaking, but actually it works quite well. And so on and so forth. So now, when you melt this into the main model, they're already solids. Netfab will fix some of this, but in all reality, I just will do this. I'm going to take all of the hollow objects, all the objects like this. I'll just guess here. I'm going to go to Edit, Combine. Just combine. Not Boolean stuff, just combine them so they're kind of all selected all kind of thing. Analysis, Inspector. Hey, look at this. Auto repair all. Auto repair all. Hey, look. Those are all now solids again. So you can keep going through this process until all the associated hardware is happy. And actually, something I would suggest you do for your models, if you're really gutsy, if you don't mind drilling out your models using a drill or just jabbing it with a soldering iron, don't print the bolt heads. Go out into the hardware store, buy some black steel bolts, you know, some of the plated bolts, or chrome plated for all I care, and actually put real bolts on things. Little piece of metal. You just drill a hole out there and just pop it in. With PLA, burn a hole. With ABS, drill a hole, or whatever you want to do. Just mount them as you want, and they're like, you know, $4 in, you know, little pieces of hardware from Ace, and you now have like the proper bolt patterns and the little hex heads and the inserts. If you are that picky about accuracy, use real bolts. Or, yeah. So, we're going to take actually a lot of this accoutrement and actually let's combine this. So, you can also combine objects too. So, notice I can go from here down to here and it's selected all of those. Go to edit mode, combine, there you go. So, and you can kind of start seeing how things are arranged. I would just say combine all the minimal objects and combine into one. Then go to Analysis, Inspector. If it does that, it's going to auto repair all. It's going to probably knock this one out of the park, but I honestly don't care. That little part down there, bye-bye. Actually, yeah, it's being complete, you know, cluster. But that gives us most of our object solidification. So, oh, what's that? Oh, that's actually a singular plane. So singular planes, we go bye-bye. They're not really part of the firearm. So here's the main gun, minus the mag. Do you see up here? Oh, look, the mag hole's empty. Cool. And actually, this file is really quite nice because it has no mag. And actually, the rounded parts in the grip, you can probably grind that down with a Dremel tool if you make it print thick enough and just do that all by hand. I wouldn't even try to print the extra detail. Honestly, I wouldn't bother. I would just simply acetone wipe it or get out a tool and actually sculpt plastic. 3D printing to me is more of a Pepacura equivalent. You can do a lot of things after the fact too. It's not always most efficient, but sometimes really you don't want to spend 20 hours in this software polygon by polygon trying to do that. But actually, you know, you can just sculpt by hand, especially if you're going to cast something out. If you're going to make a print and then make a cast of it, you're going to want to basically do a complete sand job on the whole thing out of ABS. Low speed, ABS, high quality. Just maximize the quality of the print. You're going to want to add some Bondo in places, sculpt it a bit, then make a cast. And that's where actually being kind of easy on the polygons might not be a bad idea. You can get a print out faster, and you're really going to dull it up anyways. If butter and, you know, bog, why even bother? So here we go. let's add this part, which is the clip. I mean, the mag, pardon me. Look at that mag. And actually, what is that? That would be something. Oh, hello. There's the scope. And actually, because the scope's independent, I would actually, once you get all scaled up, take that asset, go to export, and just save it as scope. S-C-O-P-E. Scope. That way, later on, you can go down the line and actually make it look good, and then just glue it in place. And actually, in this model, the Picatinny rail already has a good dovetail on it. You can just pop it on some glue, like you would in real life, actually. You just put it where it belongs. So, but anywho, let's just combine this into one model for a simple demonstration here. Take this, and the mag, and go to combine. And we're going to take this model, and that's actually without any of the little tops. And actually, because this is so hard to print accurately, you might even want to just print off one, cast one, or cast a few of them, and then just glue on top. Because you could easily just take that top rail piece right here, just make it out of wood for all I care. No one says when you 3D print you have to use only plastic. That, if you do, you're really limiting yourself to a lot of bad ideas. Being crafty with multi-materials actually may help you in the long run. So, there you go. Let's grab this all together. Again, combine into one unit. And boom! Now, File, Export, BR Scaled Prefix. Done. Now, I'm going to launch a program called NetFab, which I know you can't see all the settings on it, but I'll just talk you through it. You go to basically, you're going to go to add a part. You can find STLs, OBJs, all that fun stuff. Go to my desktop in this case. We're going to go to AAHLBR. Here is prefix. There you go. And actually, there's a little warning in the corner. You can't see it, but it's down there. We're going to go up here to says repair. We're going to do automatic repair, hit default repair, execute the thing, apply the repair, and then hit remove old part. And now you have a finished up part. Hit export part as STL. And then here's where it gets kind of fishy. The quotes, you can't use quotes in Windows. It kind of screws it up. So you got to take this here and do this. Actually, BR scaled, repaired. Because it's not a prefix, it's postfix. And bada bing, we have a new file. So now we have two files here in this directory. We have a prefix and repaired. Now, that's kind of weird because the prefix is 3 megabytes. The postfix, repaired, is a little over 500 kilobytes. So we're going to get rid of this, hit don't save, and now our working part is this right here, minus the scope. Actually, the scope's near too, I completely forget. Let's go to BR scaled repaired. At this point in time, that's our master file from this point onwards. It's been scaled up, and that's basically where we're going to start dicing. Now, there's two parts of 3D printing. There's slicing and dicing, which you think you'd slice before you dice, but actually it's the other way around. Dicing, like diced tomatoes, makes cubes. The cubes that actually will fit inside the cube or cylindrical print volume of your printer. In the case of slicing, that's actually what you do after you dice, and that's done in Simplify 3D or in Cura or SceneForge or whatever you want to use. My case, I use FlashPrint on the FlashForge Dreamer, and I use Matter Control something on the Rostock Max V2. So you can go to Edit, Transform, and this work gets kind of fun because obviously we can't print this like it is. Even on a big printer, you wouldn't be able to print this one piece, and also the overhangs would be atrocious. So we're going to put the firearm like it is here and start dividing things up. Now the first thing we're going to snap off here is the barrel. And I know it sounds kind of weird, but actually, in the end, all the barrels I work with, I'm going to recommend you use carbon fiber rod. It's pretty inexpensive, and actually, what I would do is go into software and remove that inner column. And I'll get into that in our program, how to actually edit game models or models in general. The problem you're into is that that's just too complicated to show you how to extrude things. But there is a way where you can basically remount a very accurate hole and just print around that hole and then shove the rod in there when you're done. A wooden dowel would also work too. You could also just print it as you see it and bore the whole thing out with a drill, but that may cause the print to shatter. So pre-drilling it with the printer being the operative part will save plastic, time, and actually cause a stronger part. So there you go. Except, so we're going to first take off the barrel here. And actually in my working directory, we're going to start a new one called toPrint. toPrint. I am very tired. It is midnight, and I have a really big job interview tomorrow for Rockwell Collins. I get my old job back for engineering and technology, technician, nerdy stuff, because, you know, the skills. So we're going to go to plane cut. Plane cut allows you to basically cut, well, on a plane. We're going to move up this magical infinite plane, and we're going to whack the top of this off. So obviously we don't want to get any of that part because we don't have to have random print there. We're going to go to about here. Up a little higher. Little higher. There you go. And you may want to cut it actually at a logical point, like right on that edge, because then when you print it, it's not as noticeable. It just kind of just fits there. But we'll just plane cut it right here to save the height, because we're going to need all the Z height we can get. Except, now sometimes it won't always fix the bottom, sometimes it will. You can dump that, follow the netfab, or pair it, and then use that as a mask for that part. So we're going to export to print. We're going to call this part 001. And I just use 001, 002 down the list. Save. We're going to do Control Z. We're going to take this exact thing and go like so. And we're going to just basically remove that part. Now, I'm going to transform this down by just a skosh here, because I think it's going to be a little tall. Then we're going to plane cut the next part. That's where it gets kind of fun, because we have to realize that that area up there might not print properly, but actually there's no space there. We can put some supports, or just let it droop and then sand and file it out later on. But everything else here geometrically looks like it's pretty good. That shelf should not be a problem. I don't see those overhangs are 45s, thankfully, which are right on the edge of printability in all reality. So we're going to go to plane cut. We're going to drag this up. And we're going to find a logical place to slice things at. And actually, I'm thinking right here, because on this axis, we are just starting to hit that round part down there. We're actually right at the apex of there. It makes some sense. Boom. And the part looks congruent on the inside. Let's go to export 002. I'm going to then do a Control Z and then find its mate. So, Control Z, flip it in its direction, and remove that from the print. And actually, that profile is so big. Personally, if you use the right kind of glue, you don't even need a dowel anyways, unless of course you drop the thing constantly. If you do, then you got bigger problems. So, transform, and you see what I'm doing here. I'm basically fitting it in the box. On this part here, we're not going to print it this way. We're actually going to declare that at the bottom later on the printer. We won't have to flip it here. We don't really bother. But this one we're going to slice off right, oopsies, my bad, here. Put it about there, give it a good finger width up there, about a centimeter or so. Except, go to plane cut. And about there. So, boom. And actually, that'll become the bottom of the print will print that direction. And I don't see any bad overhangs. There may be a little bit of deformation going on right on the edge there. You have to know your printer. You have to know the printer's, stuff. And of course, I didn't remove the Picatinny ribs yet, but basically those will all fail on the bottom or on the top in this case. So those will be a bit of a pain to work with. You could, in theory, slice this right here and then attach that part sideways, but I wouldn't do that. I'd actually just make a template and just make those out of wood, or, just print them off individually and then just glue them on top. With acetone washing and a good sanding job, you won't even notice it. So, and if you're going to cast it, even more of a nice thing. So we're going to go to Export 003, and then do Control Z, and you basically see what I'm doing here. I'm just trying to pick off parts that make logical sense. And this is why it's not the end of the world to print things like this. Now, in this one here, we're going to assume that the site isn't there. I really should not have said that in the master file, be honest here. Although, honestly, this site, if you do it right there as a plain cut, shouldn't have too many problems. Actually, the sizing so far is fitting the print bed just about right. That will fail right there, but we could add supports there later on. Or just, again, clean it up with a Dremel tool. Yeah. I mean, this also has some overhang here. We might want to put something there, except we're going to go to plain cut. And there you go. And actually, notice how wide the print bed is. There is nothing stopping you from doing 2 parts of the prop at a time. In fact, my Rostock could do not only the extra height, it's 16 inches Z, well, 15.5, versus only, 5.9 according to spec. For the FlashForge, I could do a lot more parts, do a lot more Z, and because it's also a 10-inch diameter print bed, I could stack 3 parts side by side without too many problems. So I could really print a good half of the firearm in one go. Would I do that? No, because if it fails, I lose everything, and that's not very fun. So that's why having a bigger printer, while very convenient, sometimes actually kind of puts you in too much confidence. And considering my Rostock is still not fully calibrated, and it's tied to a laptop, which is potentially a failure point, restarts, or you bump the USB jack by accident, obviously, I don't want to cook, $60 in plastic. So, there you go. That's how you take an asset, which is already solidified, and do dicing, which is a precursor to slicing on the actual printing computer. Thanks for watching.